One goal of WHONDRS is to estimate the flux of water moving through subsurface environments in very dynamic systems. However, current technology is not capable of making such measurements. To solve this gap, WHONDRS is developing new multi-parameter sensor technology that will be freely shared with the scientific community.
Here at PNNL, we're working on a sensor rod that measures the mass flux in a river groundwater exchange interface. This rod has 16 ERT electrodes that measure bulk electrical conductivity, and then 5 thermistors on an outer rod. And then on an inner rod, it measures the fluid conductivity. There's 5 fluid conductivity sensors and 2 pressure ports, and uses Archie's law to measure the porosity. The following is a setup for testing the sensor rod in the lab. Sand and water is first mixed in these buckets at a certain water content. Sand is placed in lifts in a large soil column. The sand is scraped to achieve a uniform thickness. At each lift, the sand is compacted to achieve a high uniform density. Measurements are taken at 3 different locations along the top of the sand at each lift. Each lift is approximately 2.5 centimeters, and then we scratch the top of the surface to get a more uniform packing so you don't have high density layers. This is repeated until the column is fully packed.
In the lab testing, water is pumped through the packed column to simulate groundwater and river water flows. This process has generated promising results in temperature, fluid conductivity, bulk conductivity, and pressure signals as shown here. We are seeing expected gradients in these signals which align with the changing direction of flow. These data will be modeled using PNNL-developed computational code to invert for porosity and mass flux to be compared to laboratory imposed conditions. Contact WHONDRS at pnnl.gov if you are interested in learning more.